Now, we're going to do two further examples where you start with a long equation, but you don't get something linear out the other end. You end up with something quadratic. So let me distinguish, right? This starts as a quadratic, squared, but you end with something linear, okay? Linear here, you just get two parts, that's why there are two solutions, okay? But what I'm going to show you is going to end in a quadratic, not start with one. Okay, so here are my two examples. What are we going to do with this thing? Okay, again, you rack your brain, think about your log laws, okay? What can we do with this left-hand side being that it's the sum of two logs? Yeah, me too. Okay, fantastic. When you add logs, right, those parts that become a product, right? It's exactly the reverse of when you multiply indices, you add the powers, okay? So this is going to be equal to 3, right? Now this what we have here is more or less what I have here. It's just that inside here, I have a quadratic rather than just a linear function, right? Which is why I'm going to have to end up solving a quadratic, yeah? So if I put this now in index form, I'll do a couple of things at once. Number one, I'll say, okay, this is going to be base 2 to the power of 3, right? So I'm going to get 8 over there, 2 cubed. At the same time, I might as well just expand this because I'm going to have to work with it. That's x squared plus x. So far, so good. Okay, now I have to go ahead and solve. So this is what I've really got. It doesn't factorize nicely, so you just launch into your formula, okay? What are we going to get? Start me off. Minus 1 plus or minus square root of 1 plus, because it's minus 4ac, but I have a double negative happening here, so this really should be plus 32. Very good. All divided by 2a. Okay, I'll just tidy that up just a teeny little bit. Okay, so because I ended up with a, well, I didn't end up, because I arrived at a quadratic, I now have two solutions, because quadratics have two solutions, okay? But keep in mind that as we went through this to get to this point, I kind of transformed my original problem into a different one, and then employed the quadratic. So whenever you transform the problem, we've noticed this before, whether it's using trig identities or T result, whatever, right? You need to check your original solution, your original equation with the solutions you've arrived at. Bless you. Okay. So when you have a look at these two values, minus 1 minus root 33, all on 2, and minus 1 plus root 33 on 2. Do they both work? Answer, no they don't. Just to be really, get your calculator out, to settle in your mind, because I hope the numbers here are easy enough that you don't need a calculator, but they won't always be, as I'll show you in a minute. Let's do these each. So minus 1 minus root 33 divided by 2. So we'll just put this down here. One of the solutions is minus 3.37. Okay? The other solution, minus 1 plus 2 point, yeah? Good. So here are my two values that I'm ending up with. Okay? Now I don't need to actually reach for my calculator anymore when I look at these and think about the original equation. Okay? So for instance, let's have a look at this guy. 2.37. Okay? If you go ahead and put this all in, would it make sense? Well, assuming that all of our algebra in here was correct, which I'm pretty sure it is, it should check out. Even though it's some awful decimal, it'll actually evaluate. But when you take this other value over here, right, you immediately run into a problem. Your calculator will tell you this problem, but it won't really explain it. I'll just start to write the first thing that happens. You start to think about this, log base 2 of minus 3.37. Now, before you reach your calculator, and it just tells you this doesn't work. Why doesn't this work? Okay, yeah, Jack.
Because no matter how you grow, you can't grow to a negative number.
Fantastic. Let me say that again, because the stock standard response, and maybe some of you were thinking about this, was you can't take a log of a negative number. And that is true. You can't take the log of a negative number because if you think about it, this is what the log curve looks like, okay? And it's not defined over here. Nothing is over here, right? So you've got an asymptote here. So your x is greater than 0, that's your restriction, and this is less than 0, so you're busted. But really what it means, and I'm so glad Jack said this first off, is this is about a period of time, if it's along. It's like I'm growing at a rate of 2, I'm doubling, and I'm doubling, and doubling. At what point in time will I be this size? And the answer is, it doesn't matter how far you go forward in the future, or how far back you go in the future. You can get very small, but you'll never go negative, okay? In exactly the same way that any exponential, you can go further and further and further over here, and you'll never actually hit 0, let alone cross it and become negative. Does that make sense? Okay, so therefore, as we've mentioned before, as we've seen in trig, right? Actually, right at the first line, we missed something. We should have mentioned something as soon as we wrote the first line. There are 2 restrictions implied here, aren't there? There's a restriction implied by this function, and a restriction implied by this one. What are the restrictions for each one? First one is this restriction, right? X has got to be greater than 0. That's the restriction implied by this, right? This is a different function. This looks different, right? What's the restriction implied by this? X is greater than -1. Okay, now, when you have 2 things in here, right, I need to satisfy both of them. Otherwise, the whole thing is a shambles, okay? So when I look at both of these, which one is, quote unquote, which one is more restrictive? Which one applies and is more significant than the other? Let's think of some numbers, okay? So for instance, if I pick a number like 2, okay, or 2.37, that satisfies both, doesn't it? Thumbs up, okay? If I pick a number like 1, still good. If I pick a number like 0,
it applies to both.
It satisfies this one, but it doesn't satisfy this one. Can you see? You see that? So this one, in a sense, it's kind of more picky, right? So this one overrides this one. This one is the really important restriction you need to watch for. Does that make sense? Okay, so at that point, I would say, all right, therefore, x equals only the positive one as x is greater than 0. You happy with that?